Hi, in this video we are going to discuss Euclid's division lemma and we'll try to understand the concept using example. So let's take one example where there are 13 pencils and we want to distribute these 13 pencils among 3 students. Now if I ask you the question like how many pencil each student will get, then you will simply carry out the division. So we want to divide 13 by 3. So this is a plain division. Now 3 fours are 12. So if we subtract 12 from 13, we get 1. Now we know that in this process 13, which are the number of pencil, is called as dividend. Then number of students 3 is called as divisor. The number of pencils each student got is called as quotient. And the leftover or remaining pencils are called as remainder. So these are the basic terms used in division process. Now if you take look at this example, you can find that 13 is formed by multiplying 3 and 4. So 3 fours are 12, and if we add 1 to 12 we get 13. So dividend 13 is nothing but product of 3 and 4 plus 1. So what is 13? 13 is our dividend. So this can be written as in generalized form, dividend is equal to 3. 3 is divisor into 4 is quotient and we need to add remainder to the product. Now if you take look at this division process, there will not be any other value of quotient and remainder. So you can say like these values, the quotient and remainder values are unique. So 4 and 1 are the unique values and these will not change for this particular division 13 by 3. Okay, and one of the important thing is that the value of remainder is always less than the value 3. Now let's take one example where the number of pencils are 12 and you want to distribute equally between 3 students. Now in this division, we'll write down this division as well as 3 fours are 12, and if we subtract 12 from 12 we get 0 as the remainder. Let's take one more example. If number of pencils are 2 and the students are 3, then obviously 3 will not go from 2, so 3 0 0, so 2 minus 0 is 2. Now in all the 3 cases we can see that the value of quotient and remainder is unique. So in this case there will not be any other combination apart from 4 and 0, and in this case 0 and 2. Now for this case the value 12 is formed by multiplying the divisor which is 3 into quotient 4 plus adding remainder which is 0. And in the third case the dividend 2 is equal to the divisor 3 multiplied by the quotient 0 plus remainder 2 is added. Now let's call dividend as A, divisor as B, then quotient Q for quotient, and remainder as R for remainder. So if you put this equation, we'll get A is equal to BQ plus R. Now we have discussed that the value of remainder is always less than the value of divisor. So we are calling remainder as R. So R is always less than the divisor and we are representing divisor as B. So the value of R is less than B. Now if you see carefully, the value of remainder is 0 and greater than 0. It is never coming out to be negative. So we can write it as the remainder is always greater than or equal to 0. Now this statement is called as Euclid's division lemma. Lemma is nothing but proven statement. So this is a basic proven statement of division process. Now let's write it in word form. So given positive integers, the integers are positive. Which are those integers? A and B. That means in above example they are dividend and divisor. There exists unique integers. Now what are those unique integers? Those integers are the quotient and remainder, and we are calling quotient as Q and the remainder as R. So the unique integers Q and R such that A is equal to BQ plus R, where this condition is very important. The remainder R or the value of R is equal to or greater than 0 and it is less than the divisor, that means B. So this statement is called as Euclid's division lemma. This concept is used in further deriving Euclid's division algorithm to calculate SCF of given numbers.